So the block spring system shown below is oscillating every 3 seconds. We can say 3 seconds. There is no friction between the block and the surface, so there's no B. And if the spring constant is K, which is K equals 6, what is the approximate mass of the block? Okay, so we can do X double dot M, right? That's the definition starting point. Plus K, and remember, springs are all positive. So, except for exotic cases. We don't need to talk about exotic cases yet. That's later on in the future of your academic research career, or industry. I'm not sure if industry has that much, but we might. Anyway, we divide everything by M because that is important to do. And with that said, you get a form that shows this: R squared plus K over M equals 0, which means R equals imaginary square root of K over M, which makes sense as cosine sine. But let's say if you forgot all of that, well, then it literally just gives you it over here. So yeah, here it is. This is the free and forced vibration using the mass dynamics, whatever. It literally shows you like everything, Bode plots and frequency diagrams. What else does it show? I don't know what it shows, but basically you could have gotten it from here, basically. And you could get the defined frequency rate over here, which is basically this. So omega equals square root of kn is the frequency. Why is that the frequency? Well, when you do cosine and sine, basically what happens is k divided by m square root shows up over here, and that defines the frequency rate and the period, actually. So here's a fun fact. If that's true, then we know square root of 6 over m is somewhat related to omega. And omega is actually considered angular velocity in another way. If you heard of angular velocity, you should have, because that is equal to, I mean, angular velocity is it angular? Yeah, 2 pi divided by t, which is the period. Uh, yeah. So we understood that the period oscillates every second. So basically, what I'm trying to say is that you can get the mass over here with this thing over here. So I was trying to find that in the equation sheet, like does it show you that it's 2 pi t or whatever, and I couldn't find it. So I'm assuming they don't show you that. So right before the test, remember that fact, and you should be good with this question. Um, so you do 6 divided by m equal 2 pi over t, and then you do m equal t 6 divided by 2 pi, with this has to be a square and this has a square, right? That should work. And I should have done this more properly where I put the square over here, actually, and that would have been more indicative of what's going on, but you live, you learn. Yeah. Anyways, with that said, now we can get 3 square, 2 pi square, and then 6. So you grab your calculator, turn it on, and do 3 square multiplied by 6 divided by parentheses 2 pi parentheses square, which gives you about 1.367. So that's about A if you round up. And they always do this rounding thing, so always make sure to check if your number is not quite the same. Did they round it? They might have rounded, even though it's like a big ass number. All right. 2,000 kilogram car pulls a 500 kilogram trailer. Okay, so there's a car and it's pulling a trailer that's 500 kilograms, and there's 2,000 kilograms here. The car and trailer accelerates at, so velocity equals 50 kilometers per hour, to 75 what? Accelerates. Ah, I see. So it's not static. What is the linear impulse does the car embark on the trailer? Ah, I see what they're trying to say, but it's pulls. So impulse is defined by NV, right? And it says what's the linear impulse. So all you have to do, and let's check if there's impulse equation over here. If there is, that's wonderful, and you can keep using it. Impact over here, MV. Not really. I mean, efficiency is here. That's beautiful, but I don't see impulse, which is interesting because I would imagine impulse being the first thing one of the first thing we put in energy. So quite confusing that why they don't put it in here. They probably do. I just can't find it. Half the time I'm looking at this like search board and it's there. I just can't find it because it takes like 5 hours to find. Um, it's probably here, honestly. Okay, I'm not wasting more time, but you can search yourself and find it. The solution to this is basically doing a delta MV. So it's actually impulse equals, so it's a delta P, right? Equals, this is called impulse. So MV minus MV is basically what's happening. And it's 2, 1. So you're just doing mass of the, I guess, just the car in this sense, which is 500. Just trail, sorry. And then it is, because we're looking at the impulse of the trailer, car impulse on trailer. So it is 75 minus 50, and it's assumed linear, so this is fine. That's when it's linear, you can do this because it's assuming linearity. So this is what you're assuming, and this is why it works. Uh, Either way, actually, for impulse, you can do this anytime you want. But either way, we have 5,500 multiplied by 75 minus 50, right? Is that all you have to do? No, because the linear impulse imparts on the trailer. So at a rate of one meters per second. That's acceleration. I don't think we need the acceleration at this time, but we do need to convert it to regular units because it's newtons per second. So, for example, the kilogram is imparting 1,000 over here. The hour should 1 hour divided by 60 minutes, and it's one minute over 60, so it's 3600. So 3600. So 500, so it's like divided by, so multiplied by 1,000, and then it's 3600. Now that is about this is the world of dynamics, so they do a lot of this stuff. I mean, in statics they do it too, but less so. So it's Newton. So I think they round up to A, looks like. So this is A, and we move on from here, this world. So 10 is next. 10 is a hollow cylinder, uh has a mass of 2 kilograms, a height of 1 meter in the outer diagram, the di diameter of one. Really? Diameter of one? Okay. We can check the units later. If they're wrong, they're wrong, but diameter 2 kilogram and a diameter of one. Okay. And okay, inner diameter 0.8. What is the cylinder mass moment of inertia from the perpendicular of the long braid? Okay, so there is a few ways to do this, and I'm thinking basically be a little bit lazy with ourselves because there's no reason not to. Go down to the mass over here and just plug this thing in. So we are looking at the X center, right? X or Y. So this should be it. Yeah. So basically what I'm saying is go to your damn table and learn it. Because you will be saving yourself a bunch of time if you realize the table exists. I was actually going to derive this, and I was like, no way! In a multiple choice question, are you allowed to give that kind of awful question? And I was like, no, no, they definitely have a table then. If it seems like it's impossible, it's because there's a table for it, and you have not looked at the table. Yeah. So obviously you need to realize which one's R1, R2. Looks like R1 is the bigger one, R2 is the smaller one, H is the height. Okay, I think we got everything. So R1 is the outer layer. So obviously realize that R1 equals diameter half, so 1 divided by 2. R2 equals 0.8 divided by 2. H equal 1. So in this sense, you have what is M? Mass is 2 kilograms multiplied by parentheses 3 multiplied by R1, which is 1 divided by 2, right? And then because it is squared, and then plus 3 multiplied by 3 multiplied by what? It is 0.8 divided by 2 and squared. But please don't say there's a syntax error because I didn't parenthesize everything. That would be a heartbreaker because I have to like fix everything. 1 square. And I need a parentheses on that, but I don't think we need to do that parentheses, but we'll just do it just for fun. I get 0.871666 bar, so I'm assuming that's the C, and moving on. Okay, okay. We have C done. And yeah, I'm always here is a question that's interesting. First off, you need to understand this has no slip. It says rolling completely, which means this is, and also it is a reference point thing. So you're going to see a little bit of a troubling thing over here. So first off, we need to discuss about the 3 meters per second. With the 3 meters per second, we can get a total omega over here. What does that mean? We can get V, I think it's omega R equal V. So omega equals V divided by R, right? And that turns to be V is 3, so divided by 0.8 is about 3.75. Now, when we do this, we have this circle here, but what we need to discuss is these 2 points over here, because these 2 points are now the epicenter of the frame. When we were doing this over here, we didn't really consider a frame proper, but the question says over here, if uh, if arc AB on the wheel rim measures 90, what is the velocity at point A when point B is in contact with ground? So all you have to do, and here's a trick. Omega is a universal thing. It must be applied. So with that being said, it means that these two over here, when you apply it to a velocity, so imagine V, I don't know, A, then it must be equal to the length over here multiplied by omega, because it's VA equal R omega, respective to A. I don't like how the question is phrased, respective to B, sorry, because it doesn't showcase what that means, but it does indicate what they're trying to say. So what that means is that you can do you can clear it and go to your calculator and say 0.8 square plus 0.8 square, and that equals about 1.1. So VA equal 1.13137.085, and we can write omega multiplied by 3.75, and then that equals this D. Now, this is one of the harder subjects to actually get idealized to. Why? Because in reality, what's happening is that there is there's initial velocity, right? Which is this over here. We get 3 meters per second, but that's no indication of what VA is. When this point is A, point is B, we could have something over here, we could have something over here. But here's the thing. We know it has to have a turning velocity because it's rotating this way. Imagine a force. So it's not showing all the forces, is basically what I'm trying to put down here. So there's a turning force downwards. And a turning force must be included because the translational force must be from this to over here. Because what's happening is the translational force is omega times r. And this thing works. But it's really complicated to really think about. But after you realize omega is universal in this question, it makes kind of sense. Kind of a little bit of sense. But we'll do more of this question to make more sense of it. For now, that is a good enough explanation because that's the 2A or the high school idealization of it. Later on, we'll do some kind of relative things and other stuff. A 10 kilogram block is resting on a horizontal cylinder disc. Okay, like this. The turntable at a radius 0.5. Okay. From the center, the coefficient of friction of the block is 0.2. And hopefully, yeah. The rotating disk is uniform velocity. What is the minimum angular velocity required? The disk will cause the block to slip. So this is another case of, this is actually a case of this. This is what we call centrifugal force. Okay? And it must be equal to the force of the friction of the block. And centrifugal force usually is defined by, I believe it was defined by, a lot of people define it differently, but I believe it's been a long time. But actually, you can look over here probably and they'll tell you. If not, I'll just tell you right now. But I thought it definitely told you here. Because they give you mg, come on, they would definitely give you that. Here it is. Here is the radical force given toward the center of the circle. This is called centrifugal acceleration. Well, what that means is that negative r omega squared is the force going into the circle. What that means is really simple. If I was to give a block diagram of this would be like this, right? And it'll be a sum of two forces in the r direction. And you would tell me equals 0, basically, initially. And then you would tell me what? You'll tell me that there is a centrifugal force that's going in the negative direction towards r. And then you have a positive force that is going to friction, which is 0. Therefore, CC equals CR. That's what you would tell me, right? Anyways, with that being said, and this over here is assuming a frame change, so don't worry about it. Um, there isn't a frame change here, so don't worry about it too much. For now, we have to assume this. Okay, we're done. So that means that we can do something called r omega squared equal friction mu n s, I believe. And if you want to know, yes, W equals V over R. So you can imagine V squared over R. So that would mean that, you know, V squared over R is also centrifugal force. So with that being said, we can actually solve this question now. R omega squared, right, equal mu n. Oh, I forgot the mass because it's MAC. Sorry, I forgot the mass earlier. So now I put the mass in. So we can do mu mg of this equals omega squared rm because over here when we did it last time, there's a force this way, and the force this way was Fc, and this was F friction, which is equal to mu mg, and over here is mr omega squared, which is fair enough. The disk rotates. What's the minimum angular velocity that's needed? So we can divide the m, we can get rid of that, and omega equal like mu divided by g divided by r square root is our answer. So we get our calculator now, second square root and division, and we can do mu, which is 0.2, multiplied by g, which is 9.81, and then we can do down over here, we can do r. R is what? 0.5. So in total, we get 1.9809, which is B. We get the indication that this is actually just B. With that said, we can move on. Over here. Okay, we can do this all. Why do I feel like this is two different questions? I'm matching to one. Let me check the original question diagram. It's because it is. What's going on here? Um, okay, let's do this one first. A perfect sphere moves in a frictionless incline. Which of the following increases? So it's frictionless, so it's not slipping. It is not slipping, right? Because there's no, so it's basically just falling. There's no, so if you want to roll, you need a slip. So slipless means that it's sliding. So it's not increasing angular velocity. And it's moving up, so it's going this way, which total energy never increase. This is bullshit. Angular momentum, when are you having velocity here? It must be C. Now this question is interesting. Um, Point to the original question, it is a ball is dropped at rest at 12 meters above the tube. The ball exits at 2 meters or something, and there's no air resistance. Approximately how far does the ball travel horizontally? So what I'm gonna do for this question is basically um just say find R, because for some reason I didn't get this question in properly, which means I didn't really get it. Whatever, it doesn't matter. There's a few ways to do this, and my preferred way is always go to energy usually, and I hope you do too because I think that's probably easier. Mg delta height equals 1/2 mv squared. Get rid of that. 2gh, right? Square root equal v at the exit. Um, so this is not h actually, the delta h. So second square root of 2 multiplied by 9.8 multiplied by 12 minus 10, which is 2, which is 12 minus 2, which is 10, which gives you a total of, if you do square root of everything, you get final velocity of 14 out the gate over here. Once you get out the gate, you are about to use projectile motion. So let's see if I remember this equation. Actually, you should be given this here in reality. You usually get given this stuff. If not, then yeah, here it is. So if you even if you like don't remember, you are given S equal SO plus VOT plus 1/2 AOT squared for A equal constant. And we know this is going to be what we play as because what we're looking for is R, right? And I just gave you R, which is no, 14 out of the gate. The velocity is 14, and that's the shooting velocity. So this VO is 14, basically. There is no indication of it being in another direction or something like that. So yes. So yeah. So there's a few ways to do this one. Usually what you would do is plug into a cosine sine. So what happens here is I think you can use the x direction. And you could say, well, the initial start is 2. We have 0 over here is the final. Oh, this is y, sorry. Y direction plus VO, and it's going to be sine of theta, right? Whatever 45 is, because you're going to velocity over here. T plus 1/2 g, which is going to be a minus direction because of how it works, gravity works. And then you'll have t squared. Now, with this sense, you would be able to find. Over here, we have this, as we discussed. Now, with that said, what we do is basically, I will do like this is 4.9, and this is going to be plus minus over here. 14 sine that is basically, I'm going to, this is going to be 7-2, and then it's going to be t, this is t squared, plus 2 equals 0. And now, in your graphing calculator, not graphing, in your TI-36X Pro, there's a function called poly. And if you press that poly button, you can get values there. So you don't have to do anything. So you get t equal negative 0.18507, and I get 2.20531154. Now, make sure you have it in degrees because sometimes you make a mistake and do radians instead. Biggest mistake you can make. Never liked it, but if you want to know where the thing is, over here, there's something called polynomial over here. Polyvale. You do second polyvale and put in this thing, like negative this, and you keep on doing it, and you keep on doing it, and then go down here and press solve, and you get these two values, which wonderful. Very easy way to get an answer. That's super easy, super quick, and cheap. Because in this, you don't want to waste more time, I guess. You will delete this. I mean, you can waste any time you want. It's your choice. It's your life. Is t equal to 2.205 8154. And with that sense being made, we can now go to the x direction and figure out the x. Right? Now, x has no gravity. So basically what you're going to have to do is go to, I mean, there's a few ways to do it. Now, we can just go to the same value over here and just do, because there's no S equal SO plus VO cosine 45 T. If we want, we can do that if you want. Yeah. With that being said, what do you mean by that? We can just plug in the time over here. We can get the initial SO over here in the x direction, which is called x. x final equal to, where was the initial x over here? Initial x, oh, we can call it 0, plus v, which is 14, cosine 45, and then 2.2 parentheses. It's time. Grab your calculator again, and then quit out of your thing by pressing all the way down and going to the pressing the right button afterwards. So 0 plus 14 cosine 45 parentheses multiplied by 2.2058154 is about 21 seconds. I got 21.8. 21.8. I think they rounded up to 22 meters. So we will take that and we'll say the answer is C and move on because it's probably the right answer. Otherwise, I mean, you can work on it more, but I'm satisfied with my answer. All right, a 6 kilogram sphere moves at 3 meters per second, collides with a 10 kilogram sphere. Same direction. Oh, golly. And then this is 6 kilograms, and this is 10. The 6 comes to a complete stop after the collision, so V equals 0. Oh, interesting. And the new velocity of 10 kilograms is needed. Huh, interesting. What is the ball's new after the collision? Okay, we're going to do momentum save. So in all momentum in the beginning is mv 1 plus mv 1 initial, and this is equals mv final, so m multiplied by 0 plus m, sorry, this is 2 final, V2 final, right? And you're trying to figure out the V2 final here. So V2 final equal 1 divided by M2F, which is the same mass actually. So it's just M1I, V1I plus M2I plus M2, V2I. You get the point. Anyway, so you get that, and you solve it. Let's get my calculator out and just solve it real quick. 1 divided by, what is it? Second, what is the one that's moving? What is the new velocity of the 10 kilograms? So it's a 10 parentheses, right? And you just do it. Ah, um, what is m? That's 3 multiplied by 6 plus 10 multiplied by 2.5 parentheses, which is 4.3. I got 4.3, and I hope there's an answer like that. C. Okay, 4.3 this answer. You. All right, we move on. Here is velocity here. The ball is falling, and describe the fall as v equal 32t plus 6t squared. I'm going to check the original question because that answer looks like the question looks like dog. Well, wrong, sorry. Yes, I knew that doesn't make sense. No question is going to ever give you 32 and t at the same time. 32t and then t again at the same time. I'm sure that someone made a grave error here and made a mistake. Um, you can keep the t over here, although. Is that visible enough? Do you think? Let me just fit this. If I do this, yeah, that makes sense. What's the acceleration at t equal to now? Here is that velocity? Yeah, that's the velocity. Okay. All right, that's just velocity. Therefore, we could just do one derivative and take so that's 1 plus 12t. And then you can do this is acceleration at 2 equal this. So multiply the 24, 25 meters per second. And that is, I'm going to say it right now, it is B. And hopefully you guys can move on. Yep, that's B. Okay, over here, next question. A particle starts from rest to experience an acceleration of 3 meters per second square for 2 seconds. So this is A equal 3 meters per second squared, and it's for t equal 2 seconds. The particle then returns to rest in an additional distance of 8, okay? Assuming all oscillation is uniform, what is the total time elapsed of the particle's motion? Starts from rest, experience an acceleration of 3 meters per second and 2 seconds, so that's well, acceleration is equal to velocity over time, right? And velocity is equal to x over time if it was linear. If it's linear, right? You could say that. I would recommend not doing it this way, although. I think yeah, here is a motion category here. We can do V equal VO plus AOT, and there is S equal SO plus VOT plus 1/2 AOT squared. And I'm sure this value will be important if it was indicative of anything, but we don't need to do any of that. All we need to do is use these two equations. Looks like. So the particle is at rest initially, right? So at rest initially means that V equals 0 plus AT, which is basically 3t. And what is it asking for? So what's the total time elapsed? Total time, that we could definitely do that. So for 2 seconds, right? So 3 multiplied by 2 equals 6 meters per second, right? That is here. I mean, wait a second. Is this say decelerating in any way? Where's the deceleration? Let me check the original question again. No, that is correct. Okay. Hmm. So that would mean we need a distance. Okay, we got distance. A particle then returns to rest in, okay, it's a particle. Okay. So we know it's 6 meters per second, right? And then we have, okay. We really don't know what a T2 is, but I'm assuming what you have to do is use the second equation because that's the only thing they're giving. They're giving a displacement, which means you need to have a, okay, I think I kind of get what they're trying to do. So first of all, 2 seconds is used up, so it's 2 seconds already used up. Remember that. So if we use this, so and now we're dealing with the T2 basically is what they're saying, and then T2, and the question is asking T total, which is equal to T1 plus T2. Okay. With that said, we're going to start over here with VO equals 6 meters per second. That's the only information we really know. Okay. And with that said, we can go over here, and then we can know the final, which is 8 equals 0 plus 6t plus 1/2 AOT square. So we know the initial and final. We know this. We don't know A. What that means is that we need another equation for A. And luckily for us, we kind of have an equation for A, which is basically this equation. So A equal V minus VO divided by T. We know the initial condition of this is equal to, the final is 0. So we know that this is 0 minus 6 divided by T. Huh. Okay, we're going somewhere. So if you plug this in here, we get 8 equals 0 plus 6t plus T2 plus 1/2 parentheses negative 6 divided by T over T squared. T squared drops out. So basically we have 8 equals 0 plus 6t 2 plus 1/2 negative 6 T2. So that would mean, so this is minus 3. This is minus 3, so it's 3. So 8 equal 3t, right? So t equal 8 divided by 3. Yeah, and I could just get that here. Is about 2.666 plus the only 2 seconds that's spent is 4.6. So it's 4.6, that is C. Yeah, that took a while. Next one, the location of the particle moving in the xy plane is given by a primary equation, x equal t squared plus 4t. And this is when I think this is when I finally figure out how to scan more cleanly in this whole thing. And y equal negative 4t squared minus 6t 6. Where x and y are in meters and t is in seconds, what is the particle velocity at, this is just string dx dt equal 2t plus 4, and this dy dt equal 1/2 t minus 36t5. And then we plug into here, and then we square root it. So if you plug 4, we get 8, 12 equal that, and we get a calculator out here. 1 divided by 2 multiplied by 4 minus 36, 4, no, multiplied by 4, man. And then the square root of 5, which is what? No, 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 no. This is something wrong. Let me look at the original question again. Okay, yeah, yeah. Okay. According to this, there's an error in this thing. This is supposed to not exist. So pour on this white. Okay, that is supposed to not exist, and you're supposed to fit it. Okay. So delete that, and that turns into basically 6 apparently. Yeah, that didn't make any sense. Um, the number I got was like too big for anything to work, and I was like, no, that's definitely something is fishy. Minus 6 is I get negative 4. And then that is 12 squared plus 16 squared, right? And you asked for the velocity, you didn't ask for the direction of it. So I'm assuming you can do second square root of 12 square, 12 square, right? Plus 16 is basically something like 12.6, which is C. So I think that is great. This gives you that. Anyways, that is C basically. Okay, all right. A projectile motion whose mass is 10 grams is fired directly upward from ground level with a minimal with the initial velocity of 1,000. Neglect errors what's the speed of projectile when it impact the ground. So you have 1,000 over here, and you hit like this and come right down. That's what it's saying. And you have 10 grams. So here's the thing. what you have to do is basically go to this equation and go to S equal SO plus VOT plus 1/2 AOT, right? I think you're getting sick of it, but we're doing S equals 0 basically. And the initial velocity was 1,000 straight upwards, so it doesn't really matter, minus 4.9 t squared is supposed to be square. And you can plug that into your calculator, same way I showed you last time with polysolve. And then I'm pretty sure with this said, I can do 1,000, 0. If I solve this, there's two answers here, which is t equals 0, and another one is t equal 110, 123 divided by 49. So in a sense, we found the t. Now, what is the speed at that point? You just have to look at the velocity of that. So we look over here, and we do v equal VO minus 9, g equal t. So v equal VO minus 9.8 multiplied by 10,000 divided by 49, apparently. 10,000, right? Yeah. So we can now quit this place and then just do 1,000 minus 9.8 multiplied by division 10, 1, 2, 3, divided by 49, which equals negative 1,000, which means, wait a second, this is a troll question. I call it troll question when it's basically the same thing again. So C, yeah, this was a troll question. Yeah, I don't know why I spent so much time on that one, when it's a troll. Um, this took way too long to understand, but I finally figured it out. Here's what's happening. So if you read the question, it's something like this. You're heading to a dock like this, and at the start, you basically have 0. It's at dark. But as the man is moving to this direction, 1 meters per second wise, you are causing acceleration that makes the boat to move. It is what's saying. So you might be moving 1 meters per second, but also the boat is moving. And the boat is moving so much that it is creating a displacement in the water. Yeah. Wow, that was a handful of words. That's a simplification. If you read that, it says a fisherman cuts his boat engine at so it is entering a harbor. The boat comes to a dead stop with its front end touching the deck. The fisherman mass is 80 kilograms. He moves 5 meters from his seat to the back to the front of the boat in 5 seconds. So that's 1 meter per second, basically. 5 divided by 5, is 5 seconds, basically. Expecting to be able to reach the dock. If the empty boat is 300 kilograms, how far will the fisherman have to jump reaching the boat? It's not even asking about it's not asking about any of the possible like jump. There's no jump. That's the mistake I made first. So what do you think you have to do to it? First of all, this is a conservation of momentum problem. So basically what's saying is NI VI in the beginning equal M VI in the final. So over here, we can say that is 0. And this is only the final survives. And there's a couple of ways to solve this, but the easiest way is by doing relativity. The reason why is because it allows us to do V fisherman prime and V boat. We can create a relationship between them because we know that the fisherman is going 1 meter per second in a direction, right? And if I choose this as positive, okay, this is plus. And then there's a boat speed, which is going to be V boat prime that works with it. So what is this is basically, if you think about it, if this velocity over here is the V boat, in total, it is creating a V velocity like this, is what it's saying. Get it? Because you're moving in a direction this way is positive, and then the boat is actually added velocity goes the other way. Okay? To the fisherman, and vice versa. So clearly the V boat is the wrong direction. It's gonna be a negative velocity. That's counteracting the V meters per second, right? And what that allows us to do is say M fisherman, V fisherman, plus M boat, V boat. You got a relationship here. Now you can add, yeah, MF parentheses 1 plus V boat, plus M boat, V boat. Okay? With that said, equals 0. That's an equation that I can stand by. MF plus V boat by MF plus MB, V boat equals 0. And that is the equation we have. And you can kind of see what's happening here, right? We have a relationship between we have one unknown. We have only one unknown. So therefore, we can use this over here and say parenthesis we could do M F plus M B parentheses V boat equal negative mf, which we expected. FB boat uh, V boat equal negative mf divided by mf plus mb. To be clear here, there's so much other stuff in this question that this is an inaccurate. In real life, you probably won't get this effect. There will be other stuff that happen, but this is what the question is asking. Uh, so mf is a fisherman, which is 80. And then it's 80 plus MB, which is 300. And now here's the thing. This is probably the question that a lot of people will not get. This is one of the questions that will in the actual exam probably a lot of people will not get. But luckily, you only need like a 60% to pass. So this is one of the questions that you can just say, okay, yeah, and move on. But S equal negative 0.2105, and then you can multiply this by 5 seconds because 5 seconds passed. And then that will give you negative 1.05, which will round up to 1.1. And that's how you solve it. That's simply how you solve it. Oh, you can't see that. Sorry. There you go. I don't know why when I start Zoom, my picture is always there when I need to show you the whole board. So it's 1.1. So we can clarify here to be A and move on. Here's the next question over here that you will need to use. I'm going to go to my thing over here because this also requires a little nuance here that the question doesn't really showcase too often. The elevator is 12 stories building, has a mass of 1,000. Its max velocity and max acceleration is 2 meters per second and 1 meter per second square, respectively. A passenger with mass of 75 is in the bathroom scale, and if the max, okay, and then blah blah blah, you want to read there basically with the 1 meter per second square in the maximum. So if you look over here, this is a lot of early confusion for people. This is moving downwards, right? So you see the sum over here, and that is how you get MA. So here is constant, but in this intermediate field, when it's not constant, you see that gravity doesn't go smaller, but the normal force does. What's happening when you go down is basically the acceleration goes here, moves down. It doesn't have enough force for it to have enough normal force because normal force is a force that pushes. But when you pull over here, the normal force goes greater. But look over here, Fg is constant. It doesn't change whatever happens. It's the normal force that changes. So with that visualization given to you, you can solve this question. You can imagine what's happening here is basically the same situation. A human in here, and your sum of F equal basically 75 parentheses 9.8 initially, and then you have a plus 75 multiplied by 0 multiplied by 1 because this is m multiplied by acceleration equal something. And that 0.1 is the normal force becoming so much greater than. So if I put that into a calculator, multiplied by 1, so it's 810. I get about 810. So I think it's C, and we move on here. Yeah, dynamics are tricky a little bit sometimes, you know. A 200 kilogram car pulls a tractor of a 500 kilogram trailer. Okay, the car and trailer accelerates with 50 to 75 kilometers at a rate of 1 meter per second square. What is the impulse? What impulse does the car impart to the trailer? Didn't we already do this? I swear we already did this. Um, yeah, we did this already. Uh, Same question from different sources, I guess. Um, okay, we can do it again. So there's a 2,000 kilogram car and a 5,000 kilogram cart, right? So 2,000 over here, and you're moving something that's like this. So basically what's happening, the linear impulse is basically just doing what we did last time, which is delta mv. So m parentheses v2 minus v1. So it's 75. So what 2,000 parentheses multiplied by 75 minus 50. And you get something like value that doesn't make, oh yeah, you have to multiply by 1,000 and divided by 36000. I'm doing a little bit fast because we did this before earlier. Yeah, and we get that obviously because yeah. Anyways, I'm shocked that I didn't catch that. Yeah, okay, interesting. All right, I got the same answer, so yeah, it's A. Whoever wants to try this question again, you're free to do it again. Over here we have in 100 oh, why is it not deleting? A 100 kilogram box is pulled along a smooth, flat surface by external 500 Newton force. If the coefficient of friction is 0.15, what is the acceleration is experienced on the block? So here is a question. There's a 100 kilogram Over here, there's a normal force of 500. There is data of 30, and then there's a block. So first we need to observe. Sometimes we need to observe first. This question is a trick question because there is a 500 and you have to do 500 sine 30 first because there is a force this way, plus minus 100 multiplied by 9.8 for the normal force, which will then be multiplied by mu, basically, is what we're doing. And that will be the force of friction. Sometimes you need to you need to be a little bit more careful about this because it's an easy one to get tricked by. If you look over here, you can because normal force you think of gravity and don't actually check it. So basically you might say, you know, you're not gonna get the right answer, basically, because you didn't multiply by 9.8 and get the right answer. So it's negative 1, 1. I got 0.09, but we can round up to the second digit, I think. But we got 0.9. So what I'm trying to put down here is 0.5. All right, put down here is that the normal force, you have to look for the other forces too. And sometimes you don't do that. And because of that, you get the wrong answer. With that said, we have the normal force now. So from that, we can say what is the acceleration experienced by the block due to external force? Yeah, so now we can do summation of fx, which is max equal what? So 500 cosine theta, and it's minus ffr, which we can now put as mu 5, actually we can just put 109.5. Why I didn't put the minus? Because it's opposite of the other direction, it's moving. So yeah, basically I made the mistake of reordering this wrong, but you flip the orders and you're fine. Basically, if you get a negative, it needs to be negative of the total movement. Basically, you calculate the rest and then put the friction in wherever is the opposite of the movement force. It's basically what I'm saying. Yeah. So 109. So I get 244. You might be thinking, ah, great, we're done. No, we have to divide that by 100, which is 2.4. 2.4. That's not an answer. Did I do something wrong? Probably. 500 cosine 30. I did cosine 0.5, didn't I? Yeah. I don't know where my brain went, but divide by 100. I get 3.24, but I think I rounded it wrong, so it is A. Yeah, that was a slight mistake there. Anyways, problem 123 refers to a particle over here. This is a particle questions. What's the particle initial velocity? Well, we can do d and dt equal basically 20 plus 8t minus 9t squared, right? And then we can plug that in initial velocity because that's 8t, 9t, and then you can just do initial velocity is at 0, so it's 20. So it's A.